Hi, good afternoon. I am Amal Abid. I am a PhD student at University of Sfax, Tunisia. It's a great pleasure for me to share with you the outcome of our research entitled Blockchain-based self-surveyed identity approach for inter-organizational business processes. This is the outline of the presentation. First, I will explain the context, issue, and objectives of our research. Second, I will present main contributions, and I will end by the conclusion and future work. Integration of business processes across organizations is a key driver of productivity gains. It's doable when there is trust, but problematic when involved organizations have a lack of trust in each other. If 3+ parties should collaborate, where to execute the process that ties them together. All business and collaboration logic is hidden within middlemen. You have to trust middlemen. However, what if we used the blockchain as a source of truth for data and logic, where logic can be encapsulated as smart contract in the blockchain? Indeed, blockchain is a constantly growing ledger that keeps a permanent record of all transactions that have taken place in a secure, chronological, and immutable way. There is no central authority, rather there is untrusted parties. It's based on distributed consensus, and logic is implemented through smart contracts. On the other hand, for collaborative processes on blockchain enables us to approach a collaborative process execution differently. Collaborative process models can be translated to smart contracts. Process execution data on blockchain enables single source of truth across the participants and full traceability. However, the blockchain's transparency feature comes at the expense of significant privacy issues. To overcome these problems, blockchain can be leveraged in conjunction with self-surveying identity, which are novel blockchain-based solutions which enable data owners to have full control over their data. Many SSI systems do not capture on ledger transactional data between individuals, which have the advantage of complying with privacy regulations. However, capturing evidence that exchanges have happened is necessary for audit, accountability, and compliance purposes. Our objectives are to apply SSI for inter-organizational business process to ensure secure interactions, balance between privacy and transparency, privacy of business secret and customer data, and transparency for audit verification. Thus, we aim to propose a blockchain-based SSI solution for UBP that ensures confidential inter-organization process execution while providing privacy-preserving traceability. We move to illustrate the background section. Digital identity are a set of identifiers and attributes that are asserted truth, right to disclose information. Information must be with the owner's consent. Digital signatures prove that the data come from right source, prove that something belongs to an identity, protect against impersonation, and the hashes protect the integrity of the data. The SSI is based on two standardized pillars to provide a decentralized and privacy-preserving form of digital identity. The first is the decentralized identifier, which is an innovative type of globally unique identifier created by the World Wide Web Consortium Working Group. And the second is the verifiable credential. A credential is a document that details the qualification ability or authority granted to an individual by a third party handling the request authority or assumed ability. All the same information that a physical credential request can be represented by a verifiable credential defined as a tamper evidence credential that has ownership, which can be cryptographically verified. This is an example of a decentralized identity, which is resolved to the document containing identity details such as public key and signature. Verifiable credentials are composed of credential identifier, credential metadata, claims, and issuer signature. The issuer signature is necessary to verify a data source. The SSI architecture is composed of three principal roles, which are issuer, verifier, and holder. The issuer is an entity that creates claims within a verifiable credential about a subject. A holder is an entity that requests or receives verifiable credentials from issuer and maintains them in a credential repository or digital wallet. A verifier is an entity that intends to verify specific attributes or claims of a subject. It may receive this in the form of verifiable presentation. However, holders have control at all times over which attributes are transferred to the verifier. The verifier can verify the origin of exchanged data by checking digital signatures. There exist multiple blockchains that offer this infrastructure. We choose to work with Biramo, which is based on Ethereum blockchain and provide mobile application API to store verifiable credentials and sign transactions and offer libraries for web development. We move to present the approach section. The proposed platform includes three main components, an SSI interface, a private permissioned blockchain, and a registry-proof smart contract, which are described as follows. So the first one, the SSI interface, exposes its functionality to the cooperative organizations through a common API, provides confidential end-to-end processes without exposing any sensitive data on chain, supports the use of existing systems and databases while incorporating blockchain technology as a reference. For the private permission blockchain, it allows only authorized users to access to the system by verifying their cryptographic keys, serves as a tamper-proof verifiable data registry as well as transaction-proof registry. For the registry-proof smart contract, it maintains traceability in a private manner. It records the hash of transaction as well as decentralized identifiers of collaborating organizations in the blockchain to ensure integrity. It allows validating that a collaborative task was performed in case of conflict or audit. We move to present different actors. First, organizations. Each organization can play the role of issuer, holder, or verifier when taking part in an inter-organizational process. The issuer, when an organization issues a verifiable credential, its deed is associated with this credential for further verification. For the holder, an organization has full control over its data, including sensitive information, and any request for accessing this data must necessarily require its confirmation. Verifier, an organization can verify the origin of exchanged data by checking digital signatures. Hence, it can confirm the validity and authenticity of shared verifiable credentials. And for the trace verifiable, this actor has access to the trace provided by the transaction registry proof, can check if an organization can check if an inter-organizational task activity was performed between collaborating parties. This is the overview of the interaction between different actors involved in our proposed approach as a PPMN collaboration diagram. The main interactions are follows. An organization that play the role of issuer issues verifiable credential to an organization holder through message exchange and an inter-organizational collaboration. Afterward, this verifiable credential can be presented to another organization, a verifier, which confirms the validity and authenticity of data by verifying the signature of issuers. The transaction proof registry records the transaction hash and deeds of interacting parties for both issuance and presentation activities. Consequently, an authorized organization, trace verifier, can check if the transaction between collaborating parties is performed. This listing illustrates the algorithm of inter-organizational process of data exchange and storage. This algorithm depicts a secure and private DITCOM between three cooperative organizations. This figure shows a simplified model of pharmaceutical supply chain as the PPM collaboration diagram. The diagram contains 7 pools, one for each involved parties: raw material manufacturer, pharmaceutical manufacturer, hospital pharmacy, hospital healthcare professional, patient, transaction proof registry, and higher authority and drugs and pharmaceutical industry. This diagram depicts many examples of data exchange between cooperative organizations in which we use verifiable credential issuance and verification, such as raw material credential, pharmaceutical credential, and product credential. For example, the red color designates the issuance of raw material credential to the raw material manufacturer, which acts as an issuer. These credentials are issued to the pharmaceutical manufacturer, which play the role of holder. This issuance transaction is recorded in the transaction proof registry after its completion. All issuance and verification transactions are recorded on the transaction proof. Consequently, the DPI can play the role of trace verifier and thus check if transactions are performed between interacting parties. We move to present the implementation section. So to prove the feasibility and validity of the proposed framework, we provide a technical description and initial implementation and execution. For the evaluation, data is stored off-chain. Only deeds and transaction hash are stored on-chain. Storing data directly on Ethereum blockchain suffers not only from confidentiality shortcomings and scalability issues, but also from being costly. So the proposed approach is dependent on Ethereum blockchain latency. These overheads can be tested by sending simultaneous requests to the transaction proof registry smart contract. The figure depicts the completion time in seconds of the trace record operation, where we send between 1 and 800 simultaneous requests. So to sum up, the experimental evaluation shows that the implementation can achieve good results with low gas cost and as well as low latency. We move to the conclusion. So in this paper, we have proposed a blockchain-based SSI approach for EUBP. It ensures confidential inter-organization process execution, particularly inter-organization message exchange between exposing any sensitive information on-chain. The SSI concept is combined with a proof registry smart contract to provide a privacy-preserving trace for further audit verification. As future work, we aim to enhance the proposed proof registry to enable enriched analysis on private data for authorized organizations. Thank you for your attention.
Thank you so much, Amal, for your presentation today. So, do we have any questions from the audience? So, I have a comment and a question, if I may. So, first of all, congratulations for getting the Best Paper Award of the AIST track. I think that this is a wonderful application of the possibilities of the blockchain technologies. And as a believer in the blockchain technology, you will always have to tell apart between the cryptocurrencies and the casino that they mean, right? And the technology that they mean and the advantages. So I have seen that you have been using the Verano based on the Ethereum blockchain. You have shown excellent applications on the smart contracts that they offer. And it is very smart that the approach that they have going following on only storing on the chain the DIDs and the transaction hashes. Because as you say, the cost, right, of storing the raw data on chain is prohibitively expensive. So my question there would be, would other blockchains or layer 2s improve the cost of storing the whole data on the chain, or still that would be something that you would not like to use because of the potential privacy issues that may have?
If I understand, we can replace the blockchain with other technology to reduce costs. This is the question?
The question would be that right now you are using the Ethereum blockchain, which has a problem because of the cost of storing the raw data directly on chain. That's why you have the second bullet, the third bullet point there.
Yes, data are stored off-chain. Each organization stores its private data. Here. So here we have a private process A, private process B, private process C, in which all data are stored off-chain in a secure manner.
Correct.
When organization will interact, so we use the SSI interface for just sending the appropriate message exchange, just the necessary of data, not to store all data on the blockchain. So
Correct. So my question would be, is the Ethereum blockchain as of today still fast enough in terms of transactions per second to operate this model in a large scale implementation?
Yes, this is the limit. Yes, this limit of Ethereum blockchain. Each 15 seconds, we wait for the new block. Yes, but we can, for SSI, the use of the blockchain facilitate the use of the public key infrastructure to have the blockchain facilitates to have addresses, to have public keys, to have the signatures, to ensure integrity. So for this approach, we can't replace the blockchain with other technology. We must still depend on blockchain to ensure the public key infrastructure and to ensure integrity of data for further verification.
Correct. Thank you so much.
Thank you.
Please go ahead, Dr. Ziemba.
Lately, I'm working on blockchain employment in auditing. Do you have some experience in such issue or not? Auditing and accounting?
In auditing and accountability? I'm now working. This paper will be. I'm now working in extending this paper to the future work of this paper is to have to improve the registry proof with to enable audit and accountability. So we will use homomorphic encryption. Fully homomorphic encryption and zero knowledge proof to ameliorate the proposed registry proof. When using homomorphic encryption, for example, we can do more computation in over encrypted data stored off-chain, and with zero knowledge proof, we can make a statement of truth for example, for identity, to have accountability, to ensure accountability purposes. So, as extension of this paper, we aim to ensure this issue, to handle this issue. So, with zero knowledge proof, to know which actor have a conflict with zero knowledge proof of identity. If zero knowledge of plain text knowledge, we will do some fully homomorphic encryption over encrypted data to make some audit in encrypted data. So you can verify the sum of operation. We can verify a threshold values verification through homomorphic encryption. So this is we are now working to address this issue of accountability and audit requirements.
Mm-hmm. I'm afraid that the application of blockchain in different areas requires a new competences of users. Yes, for example, how use blockchain in accounting and auditing a supply chain. It requires new technological and organizational and management competences.
Okay, so the approach supports the use of existing system and database. Each organization use its system as off-chain system, and then here we have an SSI API, a sample API that implements the SSI technology. So this interface. It's in the form of endpoints to use an SSI API. So each organization keep the old system, the current system, don't change its current system. Only in interaction they can use this API to ensure privacy preserving to ensure privacy between end-to-end process when there is sensitive data to communicate.
Mm-hmm. Mm-hmm. Thank you very much.